And welcome to Desk with LADYADA.
Hello, everybody. It's a LADYADA o'clock, which is not a national daylight savings time. It's my own time.
Not yet.
Not yet, but we're here. It's been an exciting weekend here in New York. Lots of walking around and seeing what's going on in the city. A lot of people are out celebrating, dancing, but we also did some engineering as well.
That's right. So I just wanted to say thank you to our community of people that were actively engaged in democracy here in the U.S.
Yay, voting!
No matter how you look at things, over 140 million plus people decided it was important enough to them to do something and vote.
That's like the highest turnout ever, right?
We'll see when all the final numbers are in.
Okay.
But I also wanted to say thank you to the poll workers who are still working.
Some are still counting.
And still will be working for a while.
Yeah.
But the civil workers and all the people who
the poll workers we saw
make this thing go, and especially to our community of people who used our resources, we used our platform to get the word out. And a lot of people in the Adafruit community said, I've never either voted or I've never even been a poll worker. And around the country, they used the resources that we put online, and they did it. So I just want to say thank you, everybody. And our commitment, as always, is let's build back better, and let's build a good future together. We have a lot of work to do, everybody. COVID is creeping in. It is literally killing us. So they're going to need scientists, engineers, people who can fix this problem, and that is us.
Yes, all of us together.
So let's do this.
Okay.
So we do Desk of LADYADA, we do STEMMA Sundays. We also do the Great Search with DigiKey.
We'll get to that later.
And we're also going to show some cool stuff. So let's kick it off, LADYADA. What is on your desk this week?
Okay, so let's go to the overhead so we can see. Well, we'll start with the STEMMA Sunday. Okay, so I put together some prototypes. So a couple weeks ago, I made two NPR 121 capacitive touch breakouts. I thought I wouldn't be able to get any more NPR 121 chips, but turns out, I think some other company is making them or something, because I can still get these chips at a pretty good price. So I thought I'd make two breakouts, one with big alligator clips and one that would just replace the current breakout we have now. So so these are nice blue STEMMA QT boards. I don't usually solder on both STEMMA QT connectors because I want to save them. But they'll be chainable, and then you can have two of these on I2C ports, so up to, let's see, there's 12 per 24 total capacitive touch sensors. That's good. Another board that came in the same panel is I got these ESP32S2 zero size boards. I saw some people make at Mega Zeros, and I was like, that's a really interesting idea. It's like a Pi Zero breakout with the same shape and pinout connections. And one of the things that people really like about the Pi Zero is it has Wi-Fi, and you can connect all sorts of Raspberry Pi hats and bonnets. Now granted it runs Linux, and that's going to be awesome and of course great for a lot of uses, but there might be some times where you want to make a battery powered project, and that's where the Raspberry Pi Zero is not going to be as great because it draws a lot of current. It doesn't have a deep sleep mode. You're still running Linux. You're kind of it's not really meant to go into a low power mode in the same way that a Wi-Fi microcontroller can go down to under 100 microamp current. So I got battery and battery charging and a battery monitor chip, STEMMA QT, and I've got, since the Pi Zero has two micro USB ports, I was like, well, let's kind of stick with that theme. So one port goes to a USB to serial converter. And that connects to the ESP32S2 debug port. So the ESP32S2, because it's native USB, you can use this port for the native USB, and that way you can upload code and bootload and connect to the REPL. But there's always this secondary hardware serial port that you can always use to get debug information, and also you can use it for uploading. So you can always upload through the debug port, which might be handy if you want to not have to switch between USB bootloading and not that way. Some people, they don't. It is a little bit more annoying to rather than having one USB serial connection that never goes away. So that's that, and then you got the auto reset circuitry for the USB serial converter, NeoPixel, and they've got 2 buttons. They're right angle buttons because I want to make it so that when you have like a bonnet on top, you can still get to the buttons because, again, like the Raspberry Pi Zero, you can reset it or put it into bootload mode. So this is the boot 0 button and this is the reset button. Two handy buttons, so you can force bootload mode. Also, you can use the boot 0 button as a button. Like there's nothing to stop you. It's just you don't want to hold it down during reset, or it'll go into bootloader mode. So I'm just gonna like try this out. What I tried to do with I can try loading up the schematic. What I tried to do with this design was have the pins match up as much as possible with the Raspberry Pi Zero pins, which isn't 100% possible because the pins that are available in BCM, right, like the GPIO pins, are not going to match one-to-one with the ESP32S2. Like if it did, it would be like amazing, but a totally weird coincidence. So let's go to my computer and we can look at the board. And then I've got this schematic. Let me get rid of this side stuff. So yeah, I just added this like battery monitor so you see it's like, hi, I'm floating up here. So this is the USB serial converter and auto reset circuit, so that's the debug section. And then I've got this NeoPixel, I've got the STEMMA QT, standard LiPo charger I like, buttons. We have this double click detection, so if you use the UFT bootloader, you can double click to go into bootloader mode, which is kind of cool. One debug LED, an on power LED, regulator, the AP2112, and then it selects between USB or battery. Okay, and then, so this is the ESP32S2, so you see like I labeled every pin with like the pin it is. So this is like D1, D2, D3, D14, and like I don't know why this is D10. I made some mistake here. I'll figure that out later. But for the most part, like every pin is labeled by the pin number it is. So like D40 is I of 40. But then when you go to Raspberry Pi model pinout, so sometimes like I'm lucky, it's like D4 can go to GPIO4 and D2 can go to SDA and D3 can go to SCL. So these are like this. So like D3 is D3 on both of them. But then some of them I couldn't do. Like for example, this is GPIO 23 and GPIO 24. But if you go to the Raspberry Pi, like those literally don't even exist. Like it goes from 21 to 26 and then to 33. Like there's no IO 24. So I did what I could. So like 21 I could match up, and 13 I could match up, and 5 and 6 and 12, 7, 8, 9. At the SPI port, those I didn't match up because I wanted those to be on the hardware, like the high-speed SPI. These ones, 14, 15, 18 I could do, 17, 4, 3, 2, so like about half of them basically. Half of them I could match up as best I could, but the other half it's like, well, like there was just no, GPIO 26 or something, so that's that. So, or GPIO 26 actually is not accessible because it's used for the PSRAM. So that's what it is. So that's the new designs. I'm going to bring that up, and then I'll noodle with it. It's still only in WebA. Okay, and then the other stuff that we did this week, specifically today, was I worked on MagTag. Yay! So let's go again to the overhead, and I can show off this MagTag. Okay.
Yeah, so go to adafruit.com/MagTag.
Me or them?
You and them. We can all do this together. But
Did you make a special URL?
That's our special
cool.
URL. So that's a good way to remember it.
We put in like 25.
Yeah.
But we'll be putting in more later. We just we're quite busy.
A lot of the folks who have questions, make sure you read this page before you ask your question because it's probably covered.
I have a lot of things in it.
Yes. So let me scroll up to top. One thing about this is it's a refrigerator magnet. It's Wi-Fi. It's e-ink. It's low power. It's
got a cool
Python powered, and it just works. And it's low cost for all the things that it does. Has all sorts of ports. LadyAda's going to talk about it and more. But this is the big deal. This is what all those failed Kickstarters that had e-ink and like refrigerator magnets.
Well, I've always liked
never
e-ink, and I wanted
Yeah.
Wi-Fi e-ink, but then, I didn't want to do what I did with the Matrix Portal, which I had like a SAMD 51 plus an ESP32. But what I really wanted was to have it be a single chip because it would make it a lot less expensive because e-ink is already a little bit more expensive than other displays.
Yeah.
And also I wanted to take advantage of like ultra low power mode that was available when you only have one chip. I think it does make a difference. So I got it down to like, we'll do other videos where I talk about the low power. I got it down to 250 microamperes. 40 of that is the green on LED, which I don't want to get rid of. 40 of that is the ESP32S2 deep sleep mode. 100-ish is from the e-ink display. It's actually the 3-volt power. Even in deep sleep mode, I couldn't get it to draw less than 100 microamps, which is weird to me. I think I might not be maybe putting it in the right deep sleep mode, or the datasheet could be lying, which is like really likely. But the datasheet sort of implies you can get to like 1 microamp. But I couldn't do it. Anyways, it's still pretty good. 250 microamp is not so bad.
Okay, so what's on the front of this is an e-ink display.
Yeah, so the front is e-ink, and it's got, here I can like power this up so you can see it better.
Yeah,
it's got USB-C.
USB-C, everyone asked, now you get it.
Everyone's like, when are you doing USB-C?
Yeah,
now.
so now it's all everything. And then
Okay.
what's on the back of this thing? What power is this thing?
Okay, so this has a 2.9-inch grayscale e-ink display. So this does 4 levels of grayscale. So I like monochrome, but you can do some grayscale as well. The reason I went with grayscale, not tricolor, is because tricolor takes longer to refresh. And I actually think people would rather have something that refreshes very quickly or can do partial updates and then go to sleep really fast if you're going to do something that's like battery powered. I must not have... Oh, this is the one I messed with. Sorry. Let me grab one that I didn't mess with. So I started cutting traces on this because I was trying to figure out where the power is going. So let's do this one, which I did not tape down. Okay. So for this one, this one has like the side light LEDs. So these are side lighting neopixels, which means that they light up the screen. And it's got 4 buttons. And I can use the buttons to actually make the colors change. So that's my little test demo. And then this one makes it chime. Got a speaker on the back. And then ESP32S2 Rover. The 2 right angle buttons for DFU and reset. I've got the little speaker that I love so much with a Class D amplifier. And I have this connected to the shutdown pin is pulled down low by default, so you have to turn it on, so that's good for low power usage. There's a charging red LED and on green LED. There's 2 3-pin JST ports, 1 STEMMA QT port, 4 I2C sensors, a bunch of like voltage selection stuff and regulator stuff, LiPoly charger and LiPoly battery connector, and then you can plug it in, and the idea is that the battery sits, in the center here. So where you see the MagTag logo, you cover that up with your battery, so it's nice and flat. There's the debug RX and TX if you need to debug the board, an on-off switch, so you can like turn it off completely if you really want to like totally save all the power. And then all the circuitry to drive the e-ink displays. We've done e-inks for quite a bit. So, I can adjust this. Like once I get this product in a place where I really like it, I'm going to make like a 4.2-inch version, and I can make like a tricolor, and I can make one with like the 5.67 color, whatever. Because it's actually all uses the same connector and almost the same circuitry.
Yeah, check out adafruit.com/thinkink, and you can see we've been developing an entire family of e-ink displays.
Oh, there's also an accelerometer, and I'll show you why. Because Phil and I were thinking about this. We were like, well, people want to make projects that, depending on the orientation, they do different stuff. Yeah. So, now it's upside down, so you have to wait for the next cycle. But with this one, it can detect which way it's oriented, so you can display text.
Let me give you a good example. So you put this on your fridge, and you turn it to the left, and it tells you the weather on the West Coast. You turn it to the right, it tells you the weather on the East Coast. There's all sorts of things that you can do when you have an accelerometer. And,
Yeah. I think accelerometers are so much fun, and you
Yeah.
can like, tap them and stuff. So the on the back, I used these SMT standoffs, which I'm a huge fan of these days, because they just make assembly really easy. And I'm using the same magnetic feet that are used on the RGB LED matrices. But instead of for RGB LED matrix, like we have them in the store separately. When you screw them in, this now becomes magnetic, and so you can attach it to like your fridge. So I've got this countdown timer demo. Do you want to show the fridge? Showing it on the fridge?
Oh, yeah. So everyone's counting down to when the McRib is coming back.
This is what it is. This is when the McRib
Actually,
is
what
back.
they're counting down to, because you see this in the news, is there's a specific date coming up, and it's the inauguration. So this is on our refrigerator right now, and here's a little video. I just wanted to show it. And as you can see, here, I'll bring LADYADA in.
Hi.
Yeah. So as you can see, that QR code can be anything you want. This just happened to go to the transition site because they're releasing a COVID plan, and I'm looking forward to people debating about a plan because at least there's a plan now. And every day, every minute, this will update, and it turns itself on and off, low power, e-ink, and you could do anything you want, McRib, or, of course, counting down to a inauguration, which is in
Or
72
any event.
days.
Your graduation, when you go back to school.
Any event, but it's a really neat
When your
reminder.
quarantine's over.
Yeah, and that's kind of neat. And you could have it set up to do anything. When you press one of the buttons, it could go to a different countdown, or it could have how many times the refrigerator were open, because you can put another type of sensor on there.
No, the accelerometer would actually be able to tell you.
Yeah, so there's all sorts of things that you'll be able to do with this.
You
And,
can have great the text looks.
yeah.
That's why I like e-inks. And as you can sign up, we're going to be putting more of these in stock next week. And then do you want to just I'll flip through the code really fast.
Yeah, good.
Okay, cool. Let me unplug this one. Oh, there's also a light sensor. So this is, I'm going to unplug this other one.
Yeah, you could do a, we may make a larger display later, sure, why not?
Yeah, I'm just going to start with this 2.9, and then I'll probably do a 4.2 afterwards. But what I like about the 2.9 is it's not too expensive, and I could get a lot of these screens, so it was really easy to make.
It's about $30,
display.
which is
it's like $35.
Amazing.
Yeah, and it does have all the Wi-Fi, and then it can always it's easy. Like once you do one e-ink display, it's very easy to do others because the code is not that much different. The pinout is the same. You just have to load a different lookup table, and it's a different chipset, but it's nearly identical. So. I'll be able to take this and then just respin it, or you can of course just attach your own display. It'll just work.
Yeah, and someone points out the display is so good you can put a QR code on it and it works.
Yeah, it works through the camera, through the screen, through your camera.
It's so good the video of it works.
Yeah.
So
let's go to the computer and I'll show the code real fast.
Show some code.
Yeah, so the ESP32S2 is a native USB and native Wi-Fi device. So this is kind of interesting because if people have been watching the Scott deep dives, he's been doing a lot of work on getting the networking into really good shape because you can do SSL and you can do TCP and UDP sockets and all that stuff, but it's at a much lower level. We're interfacing with the ESP IDF rather than before when we were using the ESP as a coprocessor, which is totally awesome, by the way. I still love the coprocessor because it allows us to add Wi-Fi to anything for not much money. What's nice about this is it's a much faster. You actually are oh wow, it connects much faster because you don't have to have this SPI layer. You just tell it connect to this, SSID and it just does it. So here's all the includes. So there's no helper functions. This is just a raw code. I've been just crafting this over the last hour. We use just this list of capitalized variables to create the time, and then we use struct.time to create the timestamp of the event because later on we're going to subtract it from current time. We create the we create the EPD display. This is the IL0373 e-ink display, and we kind of tell it some deets like the width and the height, the rotation, grayscale, and it kind of does the lookup table for us. Oh, I do have one helper function here, grabbed from my mini QR code library that we wrote like years ago now. We wrote it for the PyPortal, but it's still working. So we can create QR codes on the fly and then actually draw little pixels for each one, create like a bitmap. Here I'm actually creating the QR code, and I add the data. So I add the URL to the QR code, and I make it, and that actually does like the mathematical calculations to draw out the matrix. I create a bitmap out of it, and then I scale it. I make it like I do some math. So I'm like, how big can I make this QR code to scale so it's it fits on the display without being too small or getting cropped. And then I add it to the right of the display. I create a large white background because the natural background with Display.io is black with white text, but I want white with black text. Then I use our font loading code. This is a great capability of CircuitPython. I can use any font, and I just have it on the disk drive. So here I've got this like BDF font. This is a standard font format. It's like any font program will be able to export it. So what I do is I load a TrueType font, and then I export the bitmap font.
Yeah, that's
size.
One thing worth mentioning is when you plug this into a computer, it shows up as a USB drive.
Yeah, because it's the native USB.
And if you've ever had to do graphics and images in any other way, it is the worst. So when you plug it in...
Yeah, I really did not want to write this code in Arduino. I could do it, but I didn't want to.
When it plugs in, you just drag and drop the font file. Oh.
Yeah, and then, so you can easily change the font. Like, I liked Arial 24, but you can use any font you like. Really, any font. People have done projects with all sorts of different fonts. I create the text area. When it starts, it just says loading, and then I anchor it sort of on the left in the center. Then I add all these graphical elements and display them. Then I connect over Wi-Fi to our local SSID. This is like this magic thing I don't completely understand, where I guess we request a pool, like a socket creator from ESP IDF, and then I create a requests, like Python requests is the function that's used in CPython to connect to websites and get JSON or text data. So we basically mimic that, except we have to do it in a little funky way because, like, we want to make sure that our code maintains backward compatibility with Airlift or with like Ethernet. So we don't just like have a request library that's ESP S2 only. We want to make sure that it works with everything, and so we have to create a session, and we give it the information on how to create the session. So this is like not this part I think is not CPython compatible, but it is. This is the only line that's different, and the rest is the same. Then I get the time, so I go to the World Time API. This is a very handy little free API, so don't abuse it because they're really nice people, and it'll give me back the date and time as like a string. I parse it out in Python, which is like way nicer than having to do it in Arduino C. And then I create, I tell the RTC what time it is. And that's kind of nice because once I tell the RTC what time it is, I don't have to keep getting the time. The internal real-time clock will now take it from here. Like I might want to check once a day and just resync in case I lose a couple seconds, but I don't have to do it more than that. And then I just repeatedly get the current time from the real-time clock. I subtract it from the event. I calculate from seconds how many hours, minutes, and days. I print it out onto the REPL, so you can see down here I'm printing it out for debug purposes. And then I update the text area and then refresh it and wait 1 minute.
The thing about Python is, even if you're not a skilled programmer, you can tell what's going on by reading the code.
It's like I just crafted this together. It only took me like 20, 30 minutes. I mostly had to remember things that I already knew. I was like, oh, how do I create QR codes? Like
147 lines of code, and you have an internet-connected Wi-Fi fridge magnet. Oh yeah, it's still going live here as we've been going on.
Yeah, well, let me. There's one thing which is going to be fixed soon, which is it doesn't. Yeah, so now actually it's funny. It's I Control-C, so now it's like displaying the REPL, and it's like, okay, what do you want? So I'm going to reload the code, and on reload you'll see it. Hopefully not crash. Yeah, it'll put in the loading text. It's connecting to the internet now, and then there you go. So it's quite fast.
Yeah.
Actually, the thing that took the longest there was calculating the QR code, I think.
Yeah, you also had pad thai, so you had pad thai between there. You had some food.
Well, I mean, before we videoed.
Yeah, but when you were doing the code.
Oh. No, I mean how long it took to refresh.
No, you didn't eat between that.
No, that would be weird. That'd be
Yeah.
like very fast pad thai.
Yeah.
Okay, so that's that. So I'm going to keep working on this. We're finding bugs. We have the ESP32S2 out. We wrote the guide this week as well. Things are slowly coming together for the ESP32S2. It's been like months and months of work, but I think people are going to really like it. I really liked writing this code. We fixed so many bugs this week. It was really a pleasure. All the stuff that worked, what's really great is all the stuff that worked for the PyPortal, that worked with all of our other, the clue, it all worked here as well, which was great. Like QR codes, like I didn't have to go out and like re-find all my QR code. I was like, oh wait, we have an example, we have a library. I loaded it, I used display.io, and it just appeared. Like that's like magical, by the way. Like I'm so used to a world where it's like you have code and you go and get it and you try to use it and it's like the compiler changed.
Yeah.
Or, you're no longer using Simsys 4, you're using Simsys 5. Well, like die in a fire. So I think that was really wonderful. So more to come. So I thought for the great search, what we would talk about is where to get these cool side angle buttons, which I like.
So is it time for the great search?
It is time for the great search.
Every single week we do the great search. It's how to find the things you're looking for on DigiKey.
Where in the world is that part I need? The great search with DigiKey.
Where in the world is that part you need? What part are we looking for this week?
So what the part I was looking for this week is a right angle tactile switch that's easy for people, not machines. I don't have any other acrylic enclosure. I want people to be able to press these buttons very easily. So they're right angle surface mount tactile buttons. So let's.
But how do we find them?
Well, we're gonna have to wait 72 days, 13 hours, 41 minutes. And while we wait, let's go to DigiKey. Okay, so let's look for these tactile buttons. So when you look for, because something is so, the more popular something is, the more names there are for it. So you can call them tactile switches, tactile buttons, or push buttons. There's like so many names. I just use the term tactile switch. Even though technically most people would think a switch is something that switches on or off and a button is something you press. I know. But this is what we call it. Current flows from positive to negative. Electrons move from negative to positive. These things are called tactile switches. It's just like life. We just have to deal with it. Push button switches, which is what you think you would be calling it. These, I think, are more like larger buttons that are like, they have like a top to them. I don't know the like real reason why some things are push buttons, some are tactile. Maybe there's like a spring contact, because I think some of these have like a tactile contact in them. A tactile contact, it's like this dome, and you press the dome, and then the dome makes the connection for you. Mysteries. But anyways, what we want is tactile switches. And there's a lot. There's not like infinite, but there's quite a few. There's about 5,000 different ones. And on one hand, there's a lot of different switches. On the other hand, there aren't really that many switches. Like, a lot of switches are kind of the same. So, like, these are 6mm tactile switches. And you see one's from C&K, and one's from eSwitch, and this is another one from APM. And you're looking at these and you're like, these kind of look the same. Yeah, they look the same. Tactile switches have a lot of common form factors that were... maybe Omron originally came up with them. Maybe, like, I don't even know. Like, 3M. Who knows? Some company came up with these, and they've just become genericized to the point where if you need a switch, chances are you don't need to get it from... It's probably not going to be like there's only one place to get it. It's probably like a generic component, which is really good because the switches that you pick... you don't want to, like, it's like a resistor, you can get a 5 or 1% resistor from everywhere. It doesn't matter whether it's from Yagyo or Panasonic or like Venkel or whoever. Similar with switches, you don't want to have to be stuck with one source of switches. I have been screwed over by that because the company is just like, we're no longer making this switch. And I'm like, well, I still need it. And they're like, tough. We're French. And I'm like, okay, and then I had to go and like look around. I eventually did find another company that was making a compatible one, but like it was a little frustrating. Anyways, enough about that. So let's look for the active and in-stock parts. We also want a surface mount, and we wanted a surface mount right angle. Okay. Why surface mount, not through hole? Because I don't want to have a through hole soldering step. You're going to get a lot stronger switches with through hole, but I'm willing to sacrifice that and just try to put more solder. One of the things I found out, actually, a lot of people who got matrix portals in the last ADA box, their switches did break off. Not a lot. It was like 10 people, but it was enough in like 1 week that I was like, wow, I need to revise the footprint for this part to give it a lot more solder so it's more mechanically stable. This is one of the things you send out 4,000 of something you learn. There you go, surface mount, right angle. Easy, so that's really nice because it will reduce the quantity down to about 75 remaining. So let's go. We'll say DigiKey site's nice and fast this week. They did some work on it, I can tell. All right, so now, okay, so next step is operating force. And this is a thing that a lot of people you're just like, well, what's the deal with operating force and how do I know what it is? The answer is you don't. You buy a couple switches with whatever force is available. It was 100, 150, 200, 250, and you physically press them and you see how you feel about them. In my opinion, 150 is kind of like a softer but clicky switch. Under 100 is like soft. And like 250 or above is like, ooh, you're like, I'm clicking. It's clicky. It's very qualitative, as you can tell. You should just get them and try them out. Here's something I learned today. You're wondering what's PIP? It's paste in pad. It's through hole, but it's designed so that you put like a big chunk of paste using your surface mount process, and then you can place the part with a pick and place machine, and it goes through the reflow, and so you get the best of both worlds. You get like the through hole physical strength, but the surface mount ease of manufacturing. I never used this trim before, but today I learned it. So congratulations, you're going to learn with me. I do not want it to be illuminated, so get rid of that. I don't want it to be flush, but I don't know if I want rectangular button or standard. So let's go check out the difference. Rectangular button, standard. I don't know. I think standard and rectangular button are kind of the same. Flush. This one's flush, and this is, yeah, I don't want that. That's like, you have something that presses it. So let's go back up here, and I don't want plunger for cap. I don't want a cap. I want it to be, all in one. And then I want it tape and reel. Don't want tubes. Don't want bulk, because I want this to go through the pick and place machine. Okay, so now let's see what we got. So there's two techniques you can use here, of course. Well, I like to, when I'm making something that's going to be manufactured, I usually like to show the prices at, 1,000 or 5,000. The reason is with the recent change where tape and reel and cut tape and DigiReel are not separate listings, the pricing is a little bit tougher to compare because you see the pricing at quantity 1. You want to see the pricing at quantity 5,000 because it's going to make a big difference. It's going to be off by like an order of magnitude, sometimes 2 orders of magnitude. Okay, so there's these, and I actually got some of these, and they were okay. They're very small, in my opinion, but they, and they're softer. Also, I felt like. Let me see what they say is the gram force. So 160. But I really liked. I kind of went, and you can see again. There's like multiple suppliers. So Panasonic makes one. And then this one, also Panasonic, and then like there's this one from C&K. Again, almost the same style. But, and then this one was just kind of cool. This is like a weird mutant, like they took a 6mm right angle and then they just like bent the legs and made it a surface mount. But this one was too big for me. Like it's kind of massive in my opinion. So this is the one I ended up with. I like this one. It's elegant, works pretty well. Again, these pads here, I made them like 20-30% bigger. This was okay, but I did have a couple break off. So I think if I were you, or if you were me, increase these pads a little bit. And you can download, oh, that's cool. You can download like a CAD model. I don't know if they have a, they do not have like the EasyCAD. But this is pretty easy to draw, this footprint. But yeah, just make the solder pads a little bit bigger. And then of course it's in a data sheet as well. So this is the one I used. I kind of like it. I mean, it's nice and clicky. It's easy for your fingers to feel, which I like that. I like it. You shouldn't have to like look at the button to see if you're pressing it. So I'm using it a lot more, especially where, let's go to the overhead. I can show. So like this design where it's going to have, a bonnet on top of it. So there's no button, like any button here wouldn't be accessible. But with these right angles, I can still get to these buttons to press them, even though there's something on top. I like that. They feel nice and clicky. All right, that's the great search.
And that's a great search. That's LadyAda and DigiKey.
Where in the world is that part I need? The great search with DigiKey.
All right, so some questions.
Yes.
Here we go.
You have 72
How
hours
many
to ask.
times can you refresh the e-ink display before it stops refreshing?
I think it's at least 10,000 times, but I'm going to try to get a number. It's a lot. I'm not worried about that.
All right. Next up. Any idea of the current draw of the fridge magnet? How often would it have to be recharged? Any deep sleep modes that can be enabled? Well, we think this is going to go for at least a month.
It can do deep sleep of 250 microamps. You could get down to 200 microamps if you remove the green on LED. I couldn't easily get a lower current draw. The regulator and the ESP draw about 100, and then the e-ink display draws 100 in deep sleep mode. So like, it's going to be tough to get below 200 microamps. I mean, like I could, but it's at some point I'm like the amount of engineering required is, I think, more than I'm willing to do for this kind of product. So you'll have to recharge it like once a month.
All right. On MagTag, do the edge lights require a reflector or light pipe to hit the screen? It looks like they hit the top edge of the e-ink.
No, they're fine. I mean, like it illuminates that area. Like they're more decorative. It's not going to be, if you turn them on all white, you're definitely going to be able to see it. But it's not meant to be like a top cover illuminator, right? Where you get like a light pipe top cover like you have for like displays like the Kindle. Like for that, it's a totally different mechanical design, and getting a proper front light for these was, I looked into the pricing and it just wasn't worth it. It was like it would have added like $10. And I was like, I don't think anybody wants that, so I just stuck 4 LEDs on there.
Deep sleep with CircuitPython code ? Or Arduino with delay.
You can use Arduino for deep sleep. Just use the ESP32 deep sleep.
Okay. Thanks for presenting good stuff for Sunday evening. Yep, thank you. Some folks said it'd be nice to have some default parameters that you could start with, like only active in stock, no marketplace, so you don't have to repeat those options each time.
Yeah,
for
it'd be
a
nice.
DigiKey, yeah.
I talked to them about that because I do kind of click the same.
Yeah, like
the
a
same
stored
thing.
actions.
Yeah, I did tell them, it's like, look, I'm always gonna have RealHOS compliant.
Yeah,
So like,
there should be a button on that little panel that says "Make my default."
Yeah, I don't know exactly what's up with that.
Yeah.
I think they're still working through this, but I think you could have it here, and then you could always just say like,
Yeah.
don't always have it be
And then
default.
reset.
But another thing is, not every. I think of all
Everything has that.
these options, not every category has these same options. So I mean, I just do it by muscle memory. I mean, it's the same as like when I open up like EagleCAD, it always opens up like this design manager, and like every single time I open, I always have to go through and I close it because I don't use it.
It's funny that.
And it drives me crazy, and it's like I save it and it doesn't save that spec.
It's funny
Every
that
time I open it, it reopens those panels. I don't
Everyone
want to.
talks about machine learning, and everybody has to make sure their microphone's muted or unmuted, on every video conference thing. My camera worked. Machine learning could tell you if your microphone and video are working. And then an application could just look at itself. What do you do every single time you open up the application?
Yeah.
You always go to view and you always turn off that panel. So it should eventually say...
It's not even like one panel. It's 4 panels.
It's not even like... That's not even hard machine learning.
It's so many panels. There's no key command to do it either,
Yeah.
I can tell.
Anyways, it's just there's a big detachment from the...
This is
The
probably
idea.
this is probably what people are like. Are you going to go to KiCad because they have like differential routing? No, I'm going to go to KiCad eventually because they don't like open up all these panels in the user interface. That's what will drive me to another piece of CAD software.
Yeah, and like someone just mentioned, when you open up a file just to read it, it's like, do you want to save it? It's just like, I've only just read it. I've never...
Hello, we just met. We just met.
So, all right. So that's our show for this week. Thanks, everybody.
Yep, more the CircuitPython stuff on the EPD and the MagTag is just starting. We're going to be doing more deep sleep this week. People can try it out. If you've got an ESP32S2, please try out the latest builds of CircuitPython because it's much improved. I've had a great experience writing this code. And we're going to be adding some more deep sleep, and I think we have some light sleep capabilities. We're going to add some more deep sleep capabilities as well that will make, these kinds of projects, doing them on Arduino has always been so challenging. I want to bring the ease of CircuitPython to e-ink displays.
All right, and that's tonight's Desk of LadyAda. We'll see you all during the week.
Think ink winter.